Okay, chapter 10.1, questions 3 through 8 and 12 through 15. We'll start with number 3. How many moles is 2.8 times 10 to the 24th atoms of silicon? 2.80 times 10 to the 20 atoms of silicon. That's what they gave us. Let's put it over 1 so I remember these are fractions. Now, we need a conversion factor that will give us, that will cancel atoms of silicon on top. So we need atoms of silicon on bottom, and then it'll give us moles on top. And we know that special number that we always use here. 1 mole is 6 point. Give myself some more space. It is 6.02 times 10 to the 23rd atoms of silicon. Atoms cancels. We're left with moles of silicon. And when we do the calculation, we get 4.65 moles of number 4. We have 2.17 times 10 to the 23rd particles of bromine. Again, I put it over 1 so I can remember I'm working with fractions. And I want to know how many moles we have. So we have 1 mole of bromine over 6.02 times 10 to the 23rd particles. Represented particles of bromine cancels, and now we're dividing 2.17 times 10 to the 23rd by 6.02 times 10 to the 23rd. And we get 0.365 moles of bromine, I believe. Actually, it's not 6.5. It's 6.0. There we go. All we're doing is dividing 2.17 by 6.02. Okay, now something a little different. How many atoms are in 1.14 moles of sulfur trioxide? 1.14 moles sulfur trioxide. And we want to get all the way over here to the end. We want to get number of atoms. That's what we're trying to get to. So we're going to have a couple of conversion factors in here. We know that the last one is going to have number of atoms. Okay? What we know about sulfur trioxide is that there are 4 atoms per molecule, 1 molecule. Right? So I'm going to use that conversion factor right here. There are 4 atoms per 1 molecule. And how many molecules of sulfur trioxide do we have? Well, in 1 mole of sulfur trioxide, we should have 6.02. You know the pattern. Times 10 to the 23rd molecules. Sorry about the writing, but I'm trying to squeeze it in. So moles of SO3 cancel, and molecules cancel, and we'll be left with atoms right here. Okay, we'll be left with atoms. And when we do the math, we get 2.75 times 10 to the 24 atoms. Number 6 is similar, but a little more complex. We have propane, C3H8. How many carbons are in there? 3 carbon atoms and 8 hydrogen atoms, for a total of 11 atoms per 1 molecule of C3H8. Now, the first one, they asked us for how many atoms of carbon are in 2.12 moles of C3H8. So what I'm going to do first is, once again, I'm going to multiply by a conversion factor. On the bottom I have moles, so that my moles will cancel. And on the top I have that favorite number of ours, 6.02 times 10 to the 23rd molecules. Okay, now I'm going to multiply by 3 carbon atoms per 1 molecule of C3H8. Molecules cancels, moles cancel, and now I'm left with just arithmetic. 2.12 times 6.02 times 10 to the 23rd times 3, which equals 3.83 times 10 to the 24th atoms of carbon. And the second part is the same thing. Right over here, we had 3 carbon atoms per molecule. Now we're going to use 8 hydrogen atoms, and we're going to find hydrogen. So I'm just going to take a little bit of a shortcut. 2.12 over 1 times 6.02 times 10 to the 23rd times 8 hydrogen atoms equals 1.02 times 10 to the 25th hydrogen atoms. That's 3, 4, 5, 6 right there. Okay, let's move on to number 7 and 8. Go ahead and page forward here. I'm going to change to a, I want to keeping with Bob Ross measure, change to a nice Van Dyke red here. This is number 7. Number 7 says, find the molar mass of PCl3. PCl3. Now that molar mass is how much 1 mole of this molecule weighs. To determine that, we need to use the atomic mass units for each of these parts of this molecule. So we'll have 1 phosphorus atom plus 3 chlorine atoms. Phosphorus has a atomic mass of 30. Let's just call it 31.0. We'll use 3 significant figures here. 31.0. And we'll have 3 chlorines, and they have a mass of 35.5. So, remember, this is 31.1 grams per mole. And so is this, 35.5 grams per mole. That's a molar mass. And when we do the math here, we're going to get 137. Let me get 138 because we used. Nope, we're adding. I'm sorry. This addition tells us that we're going to be using to the tenths right here. So we're going to have 137. What did I say? 137.5 grams per mole is the molar weight of phosphorus trichloride. And now we'll go on to number 8. I think I already worked this in the class, but I'll go ahead and work it again. What is the mass of 1 mole of sodium hydrogen carbonate? Now remember, the mass of 1 mole is its molar mass. That's exactly what we're talking about. So, we have a sodium, which is going to have a +1, and a hydrogen carbonate, which has a charge of -2. And those two can bond ionically, just as they are. We don't need to add subscripts. Now, sodium has a molecular weight of 23, let's call it just 23.0 grams per mole. I'll write it like oh, sorry about this. There is going to be 1 sodium plus 1 hydrogen plus 1 carbon plus 3 oxygens. Sodium, 23.0 grams per mole. That's its molar mass. So we're going to add that to hydrogen's molar mass, which you'll just use 1 gram per mole. And carbon rounds to 12.0 grams per mole. And 3 oxygens, which are 16.0 grams per mole each. And we multiply by 3. When we do the math, we get 23, 24, 36, plus 3 times 16 is 48.
Mike Spencer, please call extension 116.
So it's, let's say that again, 36 plus 48 is 84, 0 grams per mole. Actually, since we said we only have 1 mole, they told us we had 1 mole of this. Our units would be 84.0 grams. And that's number 8. Moving on along, that will be number 9. Sorry, we're doing 12 through 15 now. 12. If a dozen apples has a mass of 2 kilograms and 0.20 bushels is a dozen apples, how many bushels of apples are there in 1 kilogram of apples? Okay, so we know 2 things. They're equivalent statements that we can create conversion factors from. 1 dozen apples, I'm just going to put apps, equals 2.0 kilograms of apples. And 0.20 bushels of apples equals 1 dozen apples. So we got 2 equivalent statements that we can turn into 2 conversion factors. They tell us we have 1 kilogram of apples. And we need to determine how many bushels. So my answer is going to have units of bushels. I'm going to have a couple conversion factors. And so I'm going to go ahead and just anticipate 2. My last one will have units similar to my answer on top, bushels. Bushels. And this one will obviously have kilograms on bottom so that my kilograms cancel. So I'm going to use this one right here. Do you see that? 2.0 kilograms of apples equals 1 dozen apples. Right? So my kilograms are going to cancel. Now in my next one, I know that I need dozens here on the bottom. It's going to be my unit, dozens. And looking at this equivalent statement, I have 0.20 bushels of apples is equal to 1 dozen. Now my dozen cancel, and I'm left with 1 divided by 2 times 0.2. 0.10 bushels of apples is my answer. Number 13, how many moles is 1.5 times 10 to the 23rd molecules of NH3? All right, simple enough. we're going to try to change molecules into moles. So I'm writing it over here, my answer, moles. On bottom, I'm going to have the units molecules on my conversion factor. And on the top, we're going to have moles as my unit. And this should be a familiar conversion factor for us. 1 mole is 6.02. Avogadro's number again, 10 to the 23rd molecules. And we just need to do the math, and we get molecules cancel. We're left with moles, and we divide 1.5 times 10 to the 23rd by 6, and we should get something close to about a quarter. Zero 0.249 moles of ammonia. 14. We're asked how many atoms are in 1.75 moles of carbon CHCl3. Just say it that way, CHCl3. It's actually trichloromethane, but it's an organic compound. It's harder to name than the ones we've done. We have 1.75 moles of CHCl3. Now, looking at the formula, we know that CHCl3 has one carbon, 1 hydrogen, and 3 chlorines for a total of 5 atoms. And so, coming back down to our calculation, we know that 1 mole of CHCl3 has 6.02 times 10 to the 23rd molecules. Okay, those are the representative particles when we're talking about a covalent compound like CHCl3. So our moles are going to cancel. Now we need a conversion factor that has molecules on bottom and atoms on top. We have it right here. 5 atoms for every 1 molecule of CHCl3. Molecules cancels, and we're left with units of atoms. And all we have to do is multiply 1.75 times 6.02 times 10 to the 23rd times 5, and we're going to get 5.27 times 10 to the 24th atoms. And our last one, 15. What is the molar mass of calcium sulfate? Calcium sulfate. We're looking for its molar mass. Well, it has 1 calcium. The units of, let's just write this down. The units of molar mass. Well, molar mass equals the mass in grams per 1 mole. Okay? So its units are grams per mole. There we go. 1 calcium plus 1 sulfur plus 4 oxygens. Calcium has an atomic mass of 40.1 grams per mole. Sulfur has an atomic mass of 32.1 grams per mole. And 4 oxygens have an atomic mass of 4 times 16 grams per mole. And when we do the math, we have about 64, 96, 130.2, is that right? Sorry, 136.2 grams per mole is the molar mass. Okay? That is 15, and that is your first homework assignment for Chapter 10.